Hi, my name is Tanner Lowen. I'm doing my presentation over advanced SQL injection, which was originally presented at DEFCON17 by Joseph McCrae. As I said, Joseph McCrae was the original speaker. He is a penetration tester, and he is also the founder of Learn Security Online. So to start out, SQL injection. SQL stands for Structured Query Language. It's an interpreted language that is generally constructed of user-supplied data, which makes it very vulnerable. So there's three classes of SQL injection. There's in-band, out-of-band, and inferential. We'll talk about them in the next few slides. In-band, the data is extracted using the same channel that is used to inject the SQL code. This generally presents an error message telling you what you want to know. It's the most straightforward kind of attack and the easiest to do. Out of band, this one won't show up at first. You'll have to kind of do some digging to figure out this one. The data isn't presented directly on the user's browser and does not return any error message to the user. It can be retrieved using email, HTTP, DNS, several different methods. Then there's inferential. There is no actual transfer of data, but the tester is able to reconstruct the information by sending particular requests and observing the resulting behavior of the website or database server. So if an error message is returned, then it's a lot easier to reconstruct the logic of the original query. If there's no error message, then you're going to get into what's known as blind SQL injection, and you're going to have to reverse engineer the logic. So now SQL injection types. There's also three types: error, union, and blind. Easiest to hardest. Error is asking the database a question that will cause an error, and then you gather information from the error. Union is used to combine results of two or more SQL statements into a single result. And blind is asking the database a true or false question and using whether a valid page returned or not, or by using the time it took for the valid page to return as the answer to your question. So the methodology of Joseph McCrae was to first identify the injection point, which shouldn't take too long, and then determine the type of the injection, whether it's an integer, string, character, or number. And then you want to figure out what kind of attack you're going to test for. Usually you just start with the easiest and go to hardest. So determining the injection type, it's pretty simple. Usually the integer injections, you don't always need to have the single quote. Some of them will convert them to strings when you make the request, but not all of them do. Then string injections, they'll almost always have the single quote. So error-based SQL injection syntax, it's going to look a lot like this. You're going to have your site, that page, and then you're going to have your ID, what you're looking for. And then you'll put in the OR, and then you'll do in this case we did 1 equals convert, and then we're converting user into an integer. So the database will respond with some type of error message saying that you can't convert that value into an integer, and it'll tell you the actual value of the user. So you can also use this to grab other information. In the case of Joseph's slide, he used the example of you can look up the database name, the server name, the OS version, and there's whatever you want to look up pretty much. So union-based SQL injection syntax, it's very similar. You have the union select all 1. In this case, nothing may come up because you just have the 1 there. So all queries in an SQL statement containing a union operator must have an equal number of expressions in their target list. since there's just one, that doesn't equal how many there actually are. So you'll just add 2 and then 3, and you'll keep going until you get it returned with no error. So then we move on to blind SQL injection. This also looks very similar. You just do the ID equals 1, and then you want to use a wait for delay to tell whether or not it's working correctly. So if you're, in this case, we're looking for the length of the user to see if it's equal to 1. If it's not equal to 1, the page is going to come back immediately. So you can keep incrementing that until you find the length of the user, and then the page will take 10 seconds to return, or however long you want it to wait. You could put in 5 seconds for whatever. And then also you could keep using this to find like maybe the first letter of the user after you figure out how long it is. And you can keep on going, find the second letter, third letter, and obviously this is going to take quite a while to do. So building the union for the union statements. How do you know which column contains the username and other objects after you figure out how many columns there are? Well, I figured out, according to Joseph, if you put in -1 or null and then do the search, the page will load with whatever column numbers that are going to echo back data onto the page. So if the column 2 and 4 are going to echo back data, the numbers will actually appear on the page, and it'll generally look kind of weird. The numbers will just look weird on the page. So there's a little example at the bottom of the slide, ID equals null, and then union select all, and however columns you found. So then we move on to restrictive blacklists. If the site will not allow you to put 1 equals 1, then you can simply put 1 like 1, which is going to be the same thing. So little things like this can really dig you out of a hole. So now we're moving on to IDSs. This one is really simple. It's just looking for or 1 equals 1 with a comment character. That doesn't look right, but so simple ways to bypass. Here's just 4. You can put the ID equal to 2 and do 2 equals 2, or 1 is less than 2. Anything that is true will come back. So now we'll move on to our harder IDS. This one's looking for still 1 equals 1, but it's also looking for many commenting characters. Ways to bypass this: you can just do the initial string of the site and then add on or 2 equals 2 %2d %2d. That's actually encoding it into URL, the dash dash, which will also work. It's just a simple way of bypassing that. So you can also do or 1 is less than 2, same as last slide, just with the %2d instead of the dash. So harder signature based IDSs, encoding your request in hex or another language is one way to bypass. More advanced IDSs, basically you can just do different encoding schemes. In one example that Joseph had, he encoded an entire thing in Unicode. So if you can figure that out, that really helps. So a nice site that he showed on his slide was PHPIDS. This site allows you to smoke test your requests before you actually use them on the site. You can use your injections on the site and it'll tell you what regular expressions for rules that it triggers in the IDS. Once you find an injection and encoding scheme that works, the site will let you know that it'll most likely work. Web application firewalls, most of them can be identified by looking for certain indications. For example, Mott Security is identified by a /cmd.exe at the end of the URL. Another common one, WebNight, is identified after you make the request. It'll come back with a response saying http:/1.1999 no hacking. So most web application firewalls will have something like this to help you identify them. So a few common tools that he presented earlier in this slide presentation, kind of mixed it up, was wpoison. This one looks for error-based. SQL map will help you work with blind by default. You can also do union-based ones. While PD is an error-based tool, and the rest are also just as you see. So additional information that may be good to know: if programming always helps. The more you know, the easier it's going to be if you run into problems. So if you don't know a lot of programming, it may be helpful to have a friend nearby that you can ask questions. He also talked about some scanners, and you don't always want to trust the SQL scanners because they may only scan for one type of injection. So you may want to look for the other types or use a different scanner. Also different tools. It's a good idea to use more than one tool if you're using them for SQL injection. So that's the presentation in a nutshell. Again, the presenter was Joseph McRae. You can find his original presentation on YouTube. Just look up DEFCON17 Advanced SQL Injection. I also used a few of the definitions in here from our book from the class, the Web Applications Hacker's Handbook, Finding and Exploiting Security Flaws 2. I hope you enjoyed the presentation, and thanks for listening.